Hello students, welcome to Ask Math. Today we will discuss about solution of a differential equation. So if a function y equals to fx plus c is there, if this value of y satisfies a given differential equation, then this function y equals to fx plus c is called the solution of a differential equation if it satisfies that equation. For example, if there is a differential equation dy over dx equals to 2x, and if there is a function y equals to x square plus any arbitrary constant, then if this y equals to x square plus c satisfies this equation, then this y will be called its solution. So for that, let us check whether this equation will satisfy the given differential equation or not. So here, if you see on the left hand side, we have dy over dx, which means ddx of y, and let us put the value of y from here, that is x square plus c, and if I differentiate this, we will have 2x and ddx of c is 0. That means dy over dx equals to 2x, which is in the right hand side of my given differential equation. So that means this y equals to x square plus c is the solution of this differential equation, that is dy over dx equals to 2x. So we have two types of solution for a differential equation. One is called general solution and the other is called a particular solution. A general solution is where the solution contains an arbitrary constant, and a particular solution is a solution which has a specific value for that particular constant. So here y equals to x square plus c is my general solution, and for particular solution there will be condition. For example, if x equals to 3 when y equals to 2. If this type of condition is given, then we put the value of x and y in that equation. So we will put these values in this equation in the general solution, let's say, and we will get 2 equals to 3 square plus c. So here we get the value of c as 2 minus 3 square is 9, and the value of c will be minus 7. So since we have got the value of c as minus 7, so the particular solution we can write for this equation is y equals to x square minus 7. So this solution here is called particular solution for the differential equation dy over dx equals to 2x. So just remember, if you have any arbitrary constant in the solution, then that solution is general solution, and if you can get the value of c, then that time that solution is called the particular solution. And we will be discussing more about general solution and particular solution in upcoming videos. For now, we will just check the given solution is the solution of a differential equation or not. Question 1. Here we have to verify that this equation, that is y equals to a cos of 2x minus b sin of 2x, is the general solution of the differential equation d2y over dx2 plus 4y equals to 0. So here the question has given the value of y, that is y equals to a cos of 2x minus b sin of 2x. Here capital A and B are constant. So since the equation contains second order derivative, so we will differentiate this y 2 times to get the value of d2y over dx2. So differentiating both sides with respect to x, we will have dy over dx equals to, differentiating this, we will have a is constant and ddx of cos 2x is minus 2 sin 2x, minus b is constant, and ddx of sin 2x is 2 cos of 2x. That means dy over dx equals to minus 2a sin of 2x minus 2b cos of 2x. Now let us differentiate again both sides with respect to x. Then we will have d2y over dx2 equals to minus 2a is constant and derivative of sin 2x is 2 cos of 2x minus 2b is constant, and the derivative of cos 2x is minus 2 sin 2x. So the value of d2y over dx2 equals to minus 4a cos of 2x minus minus is plus 4b sin of 2x. Now since we got the value of d2y over dx2 and we know the value of y, let us put here in the left hand side of this given equation. So left hand side of the differential equation is d2y over dx2 plus 4 into y. So let us put the value of d2y over dx2, that is minus 4a cos of 2x plus 4b sin 2x, and that is plus 4 into y. So here it will be 4 into the value of y is a cos 2x minus b sin 2x. Now let us open the bracket and simplify. Minus 4a cos 2x plus 4b sin 2x plus 4a cos 2x and minus 4b sin 2x. Here you see that this minus 4a cos 2x plus 4a cos 2x gets 0, and 4b sin 2x minus 4b sin 2x is also 0. So the left hand side is 0, and you see that our right hand side is also 0. So this is my right hand side also. Since left hand side and right hand sides are coming equal, and that is because of this function, that is y equals to a cos 2x minus b sin 2x. That means this function is the solution of this differential equation, and hence it is verified. Question 2. Verify that this y equals to a cos log of x plus b sin of log of x is a solution of the differential equation x square d2y over dx2 plus x into dy over dx plus y equals to 0. So here y equals to a cos of log of x plus b sin of log of x. So here small letter a and b are constant. So since we see that there is first order derivative and second order derivative, so we will differentiate this y 2 times. So differentiating both sides with respect to x, we will have dy over dx equals to a is constant, and ddx of cos log x is minus sin log of x, and due to chain rule ddx of log x is x, 1 by x, plus b is constant, and ddx of sin of log x is cos of log of x at first, and by the chain rule ddx of log x is 1 by x. So here it will be x at denominator. So the value of dy over dx will be equal to, since the denominator is same, so here it will be minus a sin of log of x plus b cos of log of x. So this is the value of dy over dx. Now again differentiating both sides with respect to x, we will have d2y over dx2 equals to, now here we will use the quotient rule where we have to write the denominator first, that is x, and we have to differentiate the numerator, that is entire everything, minus a sin of log of x plus b cos of log of x, and subtracting and writing the numerator first, that is minus a sin of log of x plus b cos of log of x, and differentiating the denominator, that is x whole divided by x square. So let us try to simplify here. d2y over dx2 equals to x into ddx of minus a sine of log of x will be minus a is constant, and ddx of sine of log of x will be cos of log of x, and due to chain rule ddx of log x is 1 by x, plus b ddx of cos of log of x is minus sine log of x. So in front of b there it will be minus sine of log of x, and due to chain rule ddx of log x is 1 by x. And here if you notice that this ddx of x is simply 1, so 1 into this terms will be same. So let us open the bracket here. So here it will be minus minus will be plus a sine of log of x minus b cos of log of x, and whole divided by x square. Hence d2y over dx2 will be equal to, if I multiply with x, then that x and that denominator x will get cancelled, and here we will have minus a cos of log of x minus that particular x and denominator x will again get cancelled, and here it will be minus b sine of log of x plus a sine of log of x minus b cos of log of x, whole divided by x square. It might be lengthy, but this particular chapter is very easy. Okay. Now since we have got the value of d2y over dx2, and we have the value of dy over dx also, and the value of y is already given in the question, now we will verify the equation will be true or not. So we will write the left hand side of this equation, that is x square into d2y over dx2 plus x into dy over dx plus y at first. So writing left hand side here. So here the left hand side is x square into d2y over dx2 plus dy over dx, x into dy over dx, and plus y is there in the left hand side. So here we will try to put the values here, and we must get 0. So here this x square is at first, and the value of d2y over dx2 is just above here, that is minus a cos of log of x minus b sine of log of x plus a sine log of x minus b cos of log of x, whole divided by x square. And after that the second term is plus x into the value of dy over dx, that is minus a sine log x minus a sine log of x plus b cos log of x, whole divided by x. And at last we have the value of y that is given in question, that is a cos log x b sine log x, a cos log of x plus b sine log of x. So here this x square and x square got cancelled, this x and x got cancelled. So let us write everything in a single line, that is minus a cos of log of x minus b sine of log of x plus a sine of log of x minus b cos log of x minus a sine log of x plus b cos log of x plus a cos of log of x plus b sine log of x. Now here you see that this minus a cos log of x and plus a log of x gets 0, minus b sine log of x plus b sine log of x gets 0. Similarly, plus a sine log of x minus a sine log of x gets 0, and at last minus b cos log of x and plus b cos log of x gets 0. Hence, this equals to 0, which is on my right hand side. Now, since left hand side and right hand sides are coming equal, that means this y equals to a cos log of x plus b sin log of x is a solution for this given differential equation. Question 3. Verify that y equals to a into e to the power bx is a solution for the differential equation d2y over dx2 equals to 1 over y dy over dx whole square. I think this is comparatively shorter than the previous question. So here small letter a and b are constant and we have exponential function. So given y equals to a into e to the power bx is there, and we see that there is second order derivative also. So we have to differentiate this function 2 times. So differentiating both sides with respect to x, we will have dy over dx equals to a is constant and ddx of e to the power bx is b e to the power bx. Now again differentiating both sides, we will have d2y over dx2 equals to ab is constant and e to the power bx is again b e to the power bx. So this equals to ab square e to the power bx. Now since we have the value of y dy over dx and d2y over dx2, so we will verify the given equation is true or not for this function. So here as you can see, we have on the left hand side, that is d2y over dx2, and since the value of d2y over dx2 is ab square e to the power bx, so this is the thing in the left hand side. Now let us check the right hand side, that is 1 by y into dy over dx whole square. So this equals to 1 by y, the value of y is a into e to the power bx, and the value of dy over dx is ab e to the power bx whole square. So here in the numerator we will have a square b square e to the power bx whole square whole divided by a into e to the power bx. So here a and this a square will get cancelled, and e to the power bx and this square will get cancelled, and on the right hand side also I will get ab square into e to the power bx. And since my left hand side and the right hand sides are coming equal, that means y equals to a e to the power bx is a solution for this differential equation. So to verify a given function is a solution or not is a much easier task to do actually. So this much in this video. In the next video we will be discussing how to form a differential equation if the solution is given already. So till then keep practicing. See you in the next video.